Hello, I'm Kyle. I'm the technical content developer at Maple Systems. Welcome to the Maple Systems video training series. Over a series of 4 videos, we will be covering an introduction and an in-depth look into positioning within industrial automation and the parameters and configurations of positioning with the Maple Systems PLCs and the control software Maple Logic. Here in the first video, we'll be covering an introduction of positioning in industrial automation and communication setup between a Maple Systems PLC and an HMI. In the second video, we will be covering manual positioning and how it is achieved using the jog operation, basic and extended parameters, manual control ladder logic, along with a live demo. The third video will cover position control in the Modbus addresses to control a motor, along with a live demo. Then finally, in the last video, we'll be covering positioning instructions and OPR control with another live demo. The use of positioning is for precision. Generally, it refers to rotating a motor at an incremental amount to achieve a desired position. A good example of this is in a CNC machine where the spindle needs to move 6 inches. We can send a certain amount of pulses to the motor to interpret the rotational movement of the motor to a linear distance. Now, you may be wondering, how do the pulse outputs translate into motor rotation? A stepper motor has a certain number of steps per rotation. When a motor driver sends a single pulse, the motor will take 1 step. For example, if a stepper motor has a specification of 400 steps per rotation, it will take 100 pulses to rotate a quarter of a full rotation and 400 pulses to rotate the shaft 1 full rotation. This means that every step is equivalent to 0.9 degrees per step. You will often hear PTO signals when working with positioning, or pulse train output. PTO signals are electrical signals that a PLC outputs to precisely control positioning and speed. PTO signals vary from pulse width modulation, or PWM signals, because you can only change the frequency of the signal while the duty cycle is set to 50%. Before we jump into the control of the positioning program and configuration in Maple Logic, let's first look at the integrated digital I/O of the Maple PLC and how they are used in positioning. So to the left are the input signals and to the right are the output signals. The digital input pins are available to easily implement upper and lower limits for each axis by writing them to physical sensors. There are also additional digital inputs for OPR, or origin point return, which will be covered in another video. So here is a Maple modular PLC, specifically a PLC ES0808P, and there are 4 digital output pins used to send PTO signals to control up to 2 axes on both the Maple modular and also the Maple Micro PLCs. The 2 pins that are used to send pulse signals to control how many steps the motor is taking are Y10 and Y12, and then 2 more pins that determine which direction the motor is rotating are Y11 and Y13. For simplicity, we will only be programming 1 axis, even though the Maple PLCs have 2-axis position control. Y10 is setting the pulse signal, and Y11 is the logic output signal. Y10 will tell the driver how many steps will need to be taken, and Y11 will equate to what direction the motor will turn. When Y11 is on, the motor drive will send clockwise positioning instructions when pulse signals are sent. When Y11 is off, the driver will send counterclockwise positioning instructions when pulse signals are sent. Now, the last thing we'll be covering is the network configurations and communication protocols. In this setup, we'll be using a Maple HMI, specifically a CMT 3072XP, and a Maple Systems PLC, which is an ES0808P, a motor driver, and a stepper motor. The Maple HMI is the master, the PLC is the slave over Modbus TCP IP, so a typical positioning system has a controller, and in this case, that's a PLC, which determines what signals need to be sent for a particular position and speed control. Those signals are then sent to a dedicated motor driver that interprets the commands and sends the necessary pulses to the motor. In Maple Logic, starting off with the Maple Systems PLC, go to the PLC parameter tab, double click, and then go to the Ethernet tab, and here is where you'll set up your IP address for your PLC. This address will be used to communicate with the HMI via Modbus TCP IP. Then, under the Modbus tab, we'll be changing the slave ID to 1. This number will also match the HMI Modbus settings as well. Click OK. Now, in the HMI software, EB Pro, go to the System Parameters, And here you'll be adding a new device. It'll be the Modbus TCP IP master device. Double click this, and this is where you'll set your IP settings, making sure that both IP addresses of the master device and the slave device share the same subnet, but the last octet is different. And then press OK, and make sure that the station number, which is 1, also matches the slave ID in Maple Logic. And for more details, you can watch the How to Set Up Your Maple PLC and Maple HMI using Modbus RTU and TCP Communications video tutorial. In the next video, we'll be covering the positioning parameters in Maple Logic, and we will go over more detail on manual positioning. And lastly, we will show a live demo of manual positioning using a motor. I hope you enjoyed this video, and thank you for watching.